The 13th of February 2012, the European Space Agency's new lightweight launcher Vega made its inaugural flight and joined ESA's family of launchers. In its payload, 7 Cubesats, or nano-satellites. It was the first time ESA was launching such small passengers. They'd been developed by European universities, paving the way for a new era in satellite technology. Today, the potential of nano-satellites is clear to all, from big space agencies to university students. As in consumer electronics, nanotechnology is changing the way we think about satellites.
Computers have themselves been shrinking over time, over the years, going from a computer that would be many decades ago the size of a room to something which you now see on your mobile phone. And a similar analogy is happening in the space sector. We see that satellite functions have been shrinking from something the size of a washing machine to now something the size of a CubeSat, basically a satellite in a shoebox.
CubeSats were first developed by students and professors as a means to acquire experience designing, building and operating space systems. But soon everyone realized their benefits. CubeSats are also relatively low cost, since they normally use available consumer electronics. This basically means that the technology of your mobile phone can be launched into space. And the small size and lightweight also dramatically reduce launch costs. This provides an opportunity for a large amount of experimentation in space with new technologies. Of course, CubeSats have their limitations. Their small size reduces payload possibilities. For instance, the size of optical cameras inside a CubeSat limits their resolution. But for ESA, it's an interesting field.
We see them as complementary because the possibility to have a constellation of satellites, for instance, of this size, could offer advantages in terms of remote sensing, for instance, to revisit locations above the Earth on a very frequent basis and get very quick data back on things changing on the ground. Or, for instance, a constellation could be used for sensing the atmosphere and the very rapid changes that can take place in the atmosphere, or indeed for the impacts on climate.
So today, many missions with nanosatellites are being developed and over 100 CubeSats are launched every year. Their missions range from Earth observation to deep space exploration. And ESA even has a dedicated program using these satellites for technological demonstrations, like the Carmen CubeSat, developed to demonstrate technology for re-entry vehicles. Almost anything seems possible. While they still serve their original purpose, they give students the possibility to develop and build satellites for the future.
I think the younger generation now growing up, they will be the ones to figure out what to do with this technology in the best way. And we will probably see things which we never saw or even thought of before.
With nanotechnology, satellite technology has gained a valuable asset. And the technology opens up a whole new world of opportunities for the European Space Agency, as well as giving the opportunity to gain experience to the students today who can become ESA's experts of tomorrow.